We'll be talking about RS232C. The subject is Microprocessor, KCS403. My name is Gaurav Parashar. I'm from Computer Science Department. The contents of the presentation are introduction. We'll be talking about RS232 details and the block diagram. Now let's talk about what is RS232. So RS232 is actually a standard for transferring the character across the copper wire. It was produced by EIA, and the full form or full name is RS232C. So RS232 is actually used for asynchronous serial communication. Now what happens is that bits are actually encoded and then transmitted one at a time, and there are some characters which are actually added to the start of the bit and end of the bit so as for the synchronization could happen. Now, as you could see over here, this is the RS232C, where this is the connector. Now, this particular connector is actually for the connection to all the other peripheral devices. So in RS232, the connection must be less than 50 feet. The data represented is by the voltages, and the voltages are plus 15 volt and negative 15 volt. This is a 25-pin connector with specific signals such as data, ground, and control assigned to the designated pins. This specifies the transmission of the character between the terminal and the modem. And there's one important point over here is the transmitter never leaves the wire at 0 volt. When idle, the transmitter puts the negative volt, that is minus 15, on the wire. Now, however, asynchronous characters are identified. Now, in this particular case, what happens is that initially the channel is idle. Now, to start the communication, the transmitter sends 1. So when the transmitter sends 1, it tells the receiver that the transmission is going to happen. Then the data is being sent. Okay, now as you could see over here, we are sending 1, 0, 1, 1, 0, 1, 0. And after the last bit has been sent, you will send one more bit, and that is stop. And then again, this will become idle. Now, the important point over here is that before the starting of the transmission and the end of the transmission, the channel has to be idle. The starting of the synchronization would happen from the start bit, and that is always 1. The ending is always 0. The total bits that you can transfer onto the channel via RS232C is 7 bits. So, and the start bit and end bit, if we add it, then it becomes 9. For the data transmission error handling, we can use one parity bit as well. So that comes out in total 10 bits. So we can send we send 10 bits at a time. Now coming to the timing. Now to understand timing, you must understand one important thing, that the timing synchronization between the transmitter and receiver should always be same. There has to be an agreement with the transmission rate. So if the transmission is faster than receiving, the information would be lost, and that will create a problem. So when the start bit indicates to the receiver when the subsequent bits will arrive. Now, the problem of the bit rates can be actually solved using any of these 3 methods. First is the switch settings. So by setting some switches onto the hardware, you can actually check the transmission. You can use it by a program, and there can be an auto detection method. Now the baud rate. So what is a baud rate? So baud rate is actually the number of signal changes per second. And what is bits per second? This is transmission. So this measures the number of bits transmitted per second. Now in RS232, each signal change represents 1 bit. So baud rate and bits per second are actually equal. And if each signal change represents more than 1 bit, bits per second will be greater than the baud rate. This happens mostly in the modems nowadays. Now, when the transmission starts, so the combination of the start and stop with the data bits is called as a frame. So if any problem happens, then it is called as a framing error. So if we would see that if the transmitter and receiver are using different speeds, as already mentioned, stop bit will not be received at the expected time, and that would create a framing error. So see, RS232 devices may send an intentional framing error called the break. Now let us understand the transmission communication on the channels. So there are three basic methods by which a communication can happen: simplex, half duplex, and full duplex. So in simplex, only one end would be able to send. So if it is like this is the source, this is the destination, so this will always be a source, okay, and this will always be a destination. So this is the simplex mode. Now, how duplex is that if they want to send and receive, so only one at a time can happen. So this node can send the information, and after receiving it, then this node will be able to send the information. So this is called as half duplex mode. And in full duplex mode, simultaneously send and receive can happen. So we have these particular pins on the RS232C, which actually controls or are used in data transmission. So pin number 2 is for receiving, pin number 3 is for transmission, pin number 4 is for ready to send, clear to send, and ground. Now there are some limitations on the transmission. Now what happens is when the data transmission signals are being sent on the wire, so the problem is that there can be a deformation in the signal, and if the deformation happens, then the receiver should be smart enough so that any deformation happening is not it is resulting in the loss of the signal. Okay, thank you.